Hi guys. So for today's lesson, we're going to be dealing with inverse variation. So first up, some words to remember. Well, the first one is this word inverse variation. What does it mean? It's also known as being inversely proportional. So these two sorts of terms you need to be really keeping your eyes out for. If you're seeing this sort of wording, you really got to think to yourself, hang on, okay, we're dealing with this sort of stuff that we're going to be doing today. Okay, so it's a relationship between two variables. As one variable goes up, the other goes down. So it's kind of similar to like that idea of negative correlation. So as one thing goes up, the other goes down. So that's the idea behind inverse variation. It's kind of like it's the opposite of direct variation. Direct variation was when one variable goes up, the other goes up. But with inverse variation, as one variable goes up, the other goes down. So that's kind of the idea behind inverse variation. But the strategies involved and the ideas are very similar. Okay, so for example, the variables 100 meter sprint time, so how long it takes you to sprint 100 meters. So that's the first variable. And the second variable, sprint training time, so the amount of time you spend sprint training, they're inversely proportional because as your sprint training, say, increases, as one goes up, the other, your sprint time, goes down, it decreases. So these two variables here are considered to be inversely proportional. Okay, note, inversely proportional variables can be modeled by this equation here, y equals k over x, where k is the constant of proportionality. Hopefully this wording comes back to you from when we use this sort of thing in direct variation, where the model was y equals kx. So that was direct proportion, but now we're dealing with inverse proportion, and this is the one that we use for today. Okay, so some rules to remember. So when you've been told that two variables vary inversely, or are inversely proportional, etc., this is the strategy that needs to go off in your head. Okay, so step one, write down the equation, write down this model, y equals k over x. So that's step one. Step two, you want to change your x and your y to letters that represent the worded problem. So usually we're going to be dealing with things like time and cost, etc. Down here we're talking about cost and the number of people. So you want to be changing your x and your y to these variables which have a bit more meaning in the problem. Okay, so step three. Now you need to calculate this value of k by substituting for your x and y the information that's provided. Now guys, in these questions there should always be some sort of information provided. I'll let you know down in this question down here, but just that's always a must. If you don't have it, then you're not able to do these questions. So step four, you need to now return to your model. So your model was what you have up here, this sort of thing, but you want to have your x and y changed to more relevant letters. You want to go back to your model, but you want to permanently change your value of k. You don't want to see k anymore once you calculate it. So, and that's going to be your final model, and that model is used to do any sort of estimations. So that's step five. Okay, so let's do an example. Hopefully this will clear up any confusion. So the cost per person. So that's C. The cost is going to vary. It's a variable. The cost per person to hire a reception center is inversely proportional. So that's where you think to yourself, this is when we use this sort of 5-step process. Is inversely proportional to the number of people attending, and that's our other variable. So the idea is that we don't know how many people are going to attend, and we don't know the cost per person. But these two variables are linked. They're inversely proportional to one another. If there are 50 people attending, the cost is $36. So this is what I mean by the information. They've got to give you something to work with. So this is our information down here. Okay, so question A, what is the cost per person when 20 people are attending? Well, we know the cost when 50 people are attending, but what about when we have 20? So the way that we do this question is to work through these 5 steps. So step 1, y equals k over x. Step 2, well, our c is inversely proportional to n. So let c, your first letter, be your y. And here we've got n, so our x is going to be our n in this case. So that's step number 2. Change your x and y to better letters for this situation. Okay, step number 3, we need to use our information. So if n is 50, then the cost is 36. So we substitute these values for cost, 36, and n, 50. And we use this equation to figure out what our k is. So we've got to solve for k. The way to get k by itself here is to multiply both sides by our 50. That will get us k is equal to 1,800. So that is your constant of proportionality. Note, the constant of proportionality tells us the total cost for the reception centre. So that constant of proportionality actually does have some sort of meaning in this question. So 1,800, that suggests that this reception centre is going to be costing us in total $1,800. And we've got to split that up in the number of people. Okay, so step number 4, we want to be using this model. So we come back to our model where we're using C and N, but we want to change our K permanently to 1,800. So now step number 5, we want to figure out when the number of people is 20, what's our cost? Well, it's simple as just changing our N to a 20. So 1,800 over 20 equals 90. The cost is going to be $90 per person. Now, I understand some people do think to themselves, hang on, this is just common sense. We don't have to be using these 5 steps. So there's easier ways to think about it, like just doing these calculations in your head. But I really want you to be aware of these 5 steps, because when questions do get weird and tricky and a bit strange, you're able to fall back on these 5 steps. Trust me, there are tricky questions, band 5, band 6 questions, which you will not be able to do in your head, and you need to be using this sort of strategy. So make sure you're using this for today. Question B, how many people are required for the cost to be just $25 each? So we're still doing some more estimation. We're figuring out how many people. So we want to figure out our value for N, our number of people. So we use our model where we've still got our K changed to 1,800. So we want the cost to be $25. So our C changes to $25. And we need to get our N by itself. We need to solve for N. So the way to do it, N is on the denominator. We want to multiply both sides by our denominator to get rid of the fraction. And then we're left with 25N equals 1,800. Divide by 25, and you get that N is 72. So 72 people are required to make the cost per person $25. Good luck with the questions.